Okay, moving on. Um, if light is traveling with the speed c, this is Paul Gradenwitz again, and I'm just going through his response really, really slowly in video. If light is traveling with the speed c in space, then the one-time travel time of light for B to O is shorter than the one-time travel time of A to O. And yes, I think that's correct. From what I figured out last time, based on the using velocity of arctange was point. What did I find out it was? Yeah, it was 0.59306. So I keep redrawing this diagram. Um, Probably should figure out some way of doing this a little better, but here we've got O and A, and then a larger circle, which is V equals, or this is 1/6, I'll just call it 1/6, and this is negative 1/6, 1/6. Negative 1/2 is what I said was B, and event B is right there, B. Um, so if we look at the light travel time from there, um, and to there. Anyway, every observer will agree that the light from this event arrives at O at the same time that the light from that event is observed at O. No question. I think I have drawn this very poorly here. So I will plug this into Mathematica so I can get real clear lines. And now the really tricky part, because I want to have the light cone coming down from here with slope c in both directions that way. Okay, this seems to have sort of done it. Putting the light cone with the x value at ct minus 1/6 and the y value at t plus 1, and then the x value at negative ct minus 1/6 and the y value at and the t value at t plus 1. So that created a light cone right there. So I can erase this mess, paste in this mess, and what do we have? We have something too small to do any work on, so let's make it bigger. Okay, here's our observer O, here's our observer A, here's our observer B. And we've got this event observed by observer O the same time that this event is observed by observer B. We also have our x equals 0 observer here, and what x equals 0 will say is that he measures a longer distance from A to O than he measures from B to O. Now, what will observer O say about those two things? I want to construct another line, because this was 1/6, this was negative 1/6. These were the velocities. And let's figure out the point of symmetry from the point of view of O, because O is going to say that the image of this event arrived at the same time as the image of that event. He would agree that those two events are arriving at the same time, but he would not say that this event is equal to has the same distance as that event. For this, I'm going to create C, which is our hyperbolic arctangent of 1/6, and then I'm going to construct another line, a symmetric velocity. I'm just going to call it V sim of 3 tanh, no, not 3 tanh, tanh of -3 phi, var phi. The -3 times that rapidity. Then I'm going to put V symmetry times t, comma, t down here, and see if we can identify that line in the diagram. Okay, it's very close to the line that we had before, but it's a little bit further away. So once again, let's put those labels in. We've got A, we've got O, we've got B, which is the purple line, and I'm going to call this A sim. This is going to be the line that is symmetric with A from O's point of view. And so this event and this event will appear, if I could connect those, it's going to be very subtle. Okay, those two events are going to appear equidistant from the point of view of O. They're going to appear at equal redshift from the point of view of O, and they're going to appear to be simultaneous from the point of view of O. This event that actually occurs at B is going to be just slightly less distant than this event. It's going to occur at a slightly smaller redshift than that event at A. It's going to appear a little bit after that event at A. But it is going to arrive at the same time, point O, as the event at A. It's just going to be closer, smaller redshift, and smaller velocity. But that's going to be really subtle. It's going to be a really subtle difference. And guess what? Of course, as is typical, I made a very subtle error within the subtlety that I was just making, because the purple line here is V symmetry T. That is the one that is symmetric with A. And the yellow line here is the negative, is exactly half the speed of light from the origin. So everything I just said was backwards. B. Okay, so B is a little bit closer. This event at B is a little bit closer than that event at A. That event at B has a slightly smaller redshift than the event at A, and that event at B happens slightly later than that event at A. But this event at A, from the perspective of O, happens at the same redshift as this particle coming through V symmetric with A, at the same time as this event at A, and at the same distance as this event at A. So with that diagram in mind, let's come back to Paul. If light traveling with the speed c in space, the one-time travel of light for B to O is shorter. The one-time the one-time travel time for light for B to O is shorter than the one-time travel time of A to O. And yes, that is true whether you use the x equals 0 interpretation or from O's point of view, because yes, because that is closer than that event there. O assumes that the light travel time of B to O assumes that the light travel time of B to O is equal to the light travel time of A to O. No, he does not. I don't agree with that because of this subtle effect. O does not assume that the light travel time of B to O is equal to the light travel time of A to O. What he would say is that the light travel time from this point of symmetry, from that event to O, is the same as A to O. He's not. The observer in the origin or an observer in O with world line with this would disagree. Well, they would both not agree that that took that time, but for different reasons. And yet the moment light of an object arrives is for all the same. Yes, all of that light, all of the light on that light cone arrives at point O at the same time, and everybody agrees on that point. It is located maybe on a different level of simultaneity, but all will agree about the event that light reaches on point. Yes. For this reason, I take the length from O to A along the light cone and map that to the other side. From O to A along that light cone and map that to the other side. For this reason, he takes this and maps it to the other side. I don't know. Let's figure out why he's doing that. Mapping it to the other side when this is clearly not symmetric with respect to that. Okay, mapping it to the other side, if you use the plane of simultaneity, which I think will go right through, should go right through there. That doesn't look even though, does it? Why doesn't that look even? I really want to fix this while I'm thinking about it. I don't think it's broken, it's just maybe there's some kind of optical illusion going on that slope doesn't look right. But if I'm correct, then a line of simultaneity should connect this point where the light cone crosses A and this point where the light cone crosses V symmetric T. So how can I solve that? I'm going to pick out two lines here, one of them being C over 6t comma t, and the other line being, I think it's this one, negative ct over 1/6 comma t plus 1. And basically, see if, I don't know if this can work or not, but I want to see if it will find me a point where those two things are equal for t, or will that break it? Yeah, it does not work because what I need to do is adjust this, probably like t minus 1 over here, and just do t here. See if that works. Yes, it gave me t is 5/7. Subtracting 1 from t on both sides seems really elegant, so I want to do that in the description here too. So here I have C put T minus 1/6, and then T, and then here again C T minus 1/1/6, and then T, and that will produce hopefully a nicer diagram. Yeah, I like that diagram better because we're not getting out of the domain. Everything's in the same domain of T. Okay, now that I have that, I know that point is apparently along the line T equals 5/7 right here. And what I want to do is construct a line. If this one has slope m equals 1/6, then what I want here is one that has a slope m equals 6. Now that had slope m equals -1/6. This one I want to have m equals -6. So the line of simultaneity through this point here, through that line here, will be x equals -6t, 6 times the speed of light, plus x naught, which will be 1/6 of the speed of light times 5/7. And then t will be t. Did I do that right? Almost. I had to add 5/7. And it is almost impossible to tell on this scale whether that line goes through the intersection of the purple and the green, or the purple and the yellow. My argument is that it's coming in on the purple. So look at this closely. I think you can say that it's coming to the purple, definitely. So wow, I feel like I practically need to restart this video because I keep getting these confused. And is B the closer one, or is it the further one? I am pretty sure the purple one is the symmetric one, and the yellow one is the non-symmetric one. In any case, there is no assumption that the light travel time of B to O is equal to the light travel time, because that would not be correct, because the line of simultaneity and the line of B are not the same. The world line of symmetry is not the same as the world line of B. I need to work it out exactly which one is actually further. I'm pretty sure I've got the diagram right here backwards. B is the yellow line, the symmetry is the purple line. And if you come over here, I apologize for not getting this right. The purple line is the line of symmetry, the yellow line is B. So that being said, do I understand why you placed the flat image of the light cone on the bottom? No, I do not understand why you did that. The level now are space-like directions. No, that doesn't make sense. The light cone are null directions. No, that doesn't really make sense. They connect objects that are all observed at the same moment. Oh, yeah. Okay, yeah, I do agree with that statement, that all the things on the past light cone of O are observed at the same moment by O, and everyone in the universe should agree that O would observe all of those events simultaneously. but from the observation, they are also a flat surface. Not really. From the observation, I can draw a window and a tree in the distance, and I can observe the window and the tree at the same time. And I can observe a bird back there in the tree and objects in the foreground and objects in the background. It's not a flat surface, it's got depth. Now you can state that I mentally did incorrectly apply the effects of Lorentz transformation. That can be. And I think right here, when you say O assumes that the light travel time of B to O is equal to the light travel time of A to O, that would be an incorrect application of Lorentz transformations. But that is why we discuss this. And as long as I understand your reasoning, we can continue. There are two areas that I don't quite understand at this point. Well, multiple areas. But one of the major ones is excluding that, saying there should be some difference between what and what. This part I don't understand. I don't, why you place things in a flat image of the light cone on the bottom, that is still kind of a mystery to me. The observations of A and B would be almost a flat surface, except A and B did not come from the same round. A came from the first round, round 1, and B came from round 3. So between R1 and R3 there's still another round, R2. So R1 is not a flat surface, R3 is not a flat surface, and R1 and R3 are not quite at the same level. You need to go symmetric. So there is some things that I'm not still understanding. I'm not sure uh, not sure if it is sound, but as long as you can understand why I can't understand your reasoning, maybe we can continue. Thanks for watching.